Hello everybody, welcome back. So for section 2, we're going to talk more about patterns and graph and relating data together, but we're going to talk specifically about linear functions. So linear functions are things that when you graph them, they make a line because the root word of linear is line. I know, it's so surprising. Okay, so our objectives for today, we're going to identify and represent patterns that describe linear functions, please ignore that word non right there. We'll just pretend like it doesn't exist. There you go. Fixed, all better. Okay, so let's look at what we're going to do. For vocabulary, in a relationship between variables, the dependent variable changes in response to another variable called the independent variable. So you can think of it this way. The independent variable is the variable that does what it's going to do. So like in the last lesson, we talked about time. Time doesn't change. Time continues to be constant. But what depended on time? When we talked about the rocket, we talked about the height depended on the time. We talked about the volume in the balloon. As you blow it up, the volume gets greater because over time you're blowing more air into it. So the dependent variable changes because of the independent variable that doesn't change. Values of the independent variable are called the inputs. So we input values into the independent. And then values of the dependent are called outputs because whatever we put into the input changes what we get out. And that's our dependent. A function is a relationship that pairs each input with exactly one output value. So every time you put something in, you always get something different out. That's kind of what that's saying. And last one, a linear function is a function whose graph is a non-vertical line or part of a non-vertical line. So essentially it's a line. A linear function makes a line. And that is all your vocabulary. Okay, so let's represent a geometric relationship. So in the diagram below, what's the relationship between the number of rectangles and the perimeter of the figure they form? We're going to present the relationship in a table, in words, in an equation, and in a graph. So if you see right here, we have the one rectangle. Well, let's review. What is perimeter? Where is the word? I was just going to circle it. Here it is. Perimeter. Perimeter is the area all the way around. Not area, but the space all the way around. So we have to count up. So if it's 6 on this side and 1 on this side, what can we assume on the opposites? Well, since it's a rectangle, this is also 1 and this is also 6. So to find the perimeter, we say 1 plus 1 plus 6 plus 6, which is 2 plus 12, which is 14. So our perimeter for that one is 14. Okay, let's look at the second one. When we have two rectangles, we have a 6 here, we also have a 6 here, we have a 1 here and a 1 here. So 1 plus 1 plus 1 plus 1 plus 6 plus 6. So we get 4 plus 12, which is 16. For our 3 rectangles, we have a 6 and a 6, and we have 1, 1, and 1. Hopefully you're noticing a pattern. We've got 1 plus 1 plus 1 plus 1, and that plus is 1, 2, 3, 4, 5, 6 plus 6 plus 6. So we've got 6 plus 12, which is 18. So what do you notice about our pattern here? Well, every time we increase the number, we increase the sides by 2 more because we're adding 2 more to each side. But what happens with the other sides? Well, they stay the same. So we're going to talk about that and write that in a few different ways. So the first way we're going to talk about is where we make a table. And we have our independent and our dependent variables. So x is the number of rectangles and y is the perimeter because the perimeter depends on how many rectangles we have. So we're going to pair them as order pairs. So if we add up, for 1 rectangle, we have a perimeter of 14. For 2 rectangles, we have a perimeter of 16. 3 rectangles is 18. 4 rectangles is 20. Do you see a pattern? There are a couple patterns that you could see. One of them is that every time you're adding 2 more to your perimeter. Or one that you could notice is that here we're taking 2 times however many rectangles we have, and then we're adding 12 every time. So we could say that in general, 2x plus 12 will give us our total perimeter depending on how many sides we have. So if we said there are, I don't know, 10 rectangles, we could find the perimeter of that without having to draw them all out and count them by taking and plugging in 10 right there. So we just do 2 times 10 plus 12. 2 times 10 is 20, and 20 plus 12 is 32. And isn't that cool? Math is so fancy. Okay, and then the other 2 ways is looking for the pattern in the table, which we just did. So how we got 2x plus 12. And then making a graph. So if we make a graph, all we do is we take and we pair our input and output values. So let me pull this table back up here that we just did. And I'm going to graph, where is it? Ooh. Give me just a second. I'm going to write them up here. 114, 216, 318, and 420. And then I'm going to change the background. That way we can use those. There we go. Okay, so we're not going to have any negative values, so I'm just going to use my positive. Okay, and then I'm going to go by 1, 2, 3, 4, 5 down here. And that's our number of rectangles. And over here is our perimeter. And over here, I'm going to go by 5s. 5, 10, 15, 20. Normally, we want to keep our labeling the same. It helps out and it makes our data make a little more sense. But because of space limitations, I'm just going to go ahead and do it like this. All right, so what we're going to do is I'm going to go ahead and take and plot these points. So I have the point 1, 14. So I go on my x-axis to 1 over here, and I go up to 14, which is right here, and I make a dot. 216, I go over to 2 here, and I go up to 16, and I make a dot. 318, I go over to 3, and I go up to 18. It's right there. And then 420, I go over to 4, and up to 20. So what does it look like this makes? Well, it makes a linear function because it's a line, right? Yes, of course. Cool. All right, fantastic. Let me go ahead and put this drawing away. Okay. So I'm going to go ahead and have you try this one and see if you can figure out the pattern that makes this relationship. So go ahead and pause the video. Remember, look for what's constant and look for what changes, just like we did with the rectangles. So pause it. I'm going to give you a couple seconds to figure it out. Well, this is what time as you need, actually, since you're pausing me. Okay, so go ahead, pause, figure it out. I'll be back. Okay, so I kind of gave you a little bit of hint, and I said look for what stays the same and look for what changes. So for this one, let's look at what stays the same. Well, let's see. I have a 3 here and 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 a 3 here. So what stays the same for all of them? Well, in our perimeter, we always have a 3 and a 3. 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 So what are we adding each time? 3 plus 3 makes 6. So we always have 6. Okay, let me make a little, I'm going to make kind of a little charty thing here to talk about our 4s. So if we have one triangle, we have 1 4. If we have 2 triangles, we have 2 4s. If we have 3 triangles, we have 3 4s. And if we have 4 triangles, we have 4 4s. So I hope you see the pattern there. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Okay, so what's happening each time is we always have 4 times the number of triangles that we have. So our formula would be 6 plus 4x, or 4x plus 6. You could write it either way. And then if we wanted to find any number that's not 4, all we have to do is take and plug in a number. So if I wanted to find the 6th one in this pattern, I just take and plug in 6 for x. So 6 plus 4 times 6. 6 times 4 is 24, and 6 plus 24 is 30. So that means that I have a perimeter of 30 for that one. Fantastic. All right. And then this one is just comparing if you have something that increases at a steady rate, or in this case, it decreases. So the table right here shows the relationship between the number of photos, x, that you take. So x is our number of photos, and then y is our memory. Okay, if you start with 512 megabytes, and every time you take a picture, so we're not taking videos, we're just taking pictures. Every time you take a picture, you use up some of your data. You have less space to store. So how much storage space are we losing every time we take a picture? Well, to go from one to the next one, we just have to take, well, what's 512 minus 509? Well, we lost, I just lost my brain. We lost 3 megabytes of data. From 509 to 506, we lost 3 more megabytes. From 506 to 503, we lost 3 more megabytes. So every time we take a picture, in this example, we lose 3 megabytes of storage space on our memory card. Okay, so it says, is the relationship linear? Well, if it increases or decreases by a constant rate, it's linear. This one, it has a constant, so yes, it is linear. So we talked about it, what it means. Okay, we need an equation. So what happens? You start with 512 gigabytes, and then every time you lose 3 gigabytes of data when you take a picture. So it's 3 per picture, or 3x. So there's our relationship. And then you can graph it by doing what we did before. 0, 512, 1, 509, 2, 506, and 3, 503. It's going to look like a little laddery thing again. Okay, because it goes down by a constant amount. My circles are not working. Sorry, guys. Okay, so it's going to decrease at a constant amount every time you take a picture. All right, that just shows what we just talked about. And there's that, and there's that. Fantastic. All right, so I hope you took notes on this lesson too, like you're supposed to. Have them in your notebook. Your homework for 4.1 and 4.2 will both be due tomorrow. I will be back tomorrow, so I will see you then. Have a great night.